right, guys, this video is on using the linear regression feature of your TI-84 calculator to come up with an equation given several points. This is really a line of best fit. It is not the same thing we were doing on the word problems because we were just picking 2 points and writing an equation. This is going to move the line around so that it fits all the data points, which will be more than 2, to the best of its ability. Now, I have shortened this down so that you never have to add 10 or 12 points because it just takes forever. But in real life, you know, if you were doing some applications, you might have a whole bunch of data points to type in. Now, there's 2 options. If you don't have your own, you can add some kind of an app. You can use the Wabbit emulator. I should probably write that on this screen. Some of you will find that easy to download. Okay. Or if you have a Chromebook, you're supposed to be able to go and find this app to download for free. It's been whitelisted by the school district is what I've been told. Okay. Also, it is sweet to do these on Desmos online calculator, but it's a whole different format. If you look in the Google Slides for the week, I posted a link to a great video on YouTube showing how to use the Desmos calculator. So if you don't have any option but Desmos, you could either watch that video first or after this one. I don't think it'll make a big difference. Well, it'd probably be helpful to watch it first. I don't know. Anyway, moving on. All right, so the learning targets today, which I was not good about putting these on the last sets of slides, but you need to be able to put your calculator data in and find the linear regression model. You need to be able to use that model to make predictions and then describe the correlation of your data and whether it's a good fit. So the first thing we have to do is turn on the correlation coefficient. So you need to take your calculator. We're going to talk about correlation, I guess, first. So when you have a set of data and they make a nice line like this, this is a strong correlation, and this particular one is going up, so it's a positive correlation. Sorry, dogs in the video. When your information, see, I always think of it as it's making a nice tight worm here, or caterpillar, or whatever you want to call him. If your data is spread all over like this and it's more like a big blob, that's much weaker correlation, okay? Or the correlation coefficient, which is called R, will be much less. Now, one more slide on this. This is perfectly linear, so it has a correlation of 1, but the line is going down, so it's negative. This is pretty tight, my little worm here. So it's negative, close to 1, but not quite 1. And this is a big blob, so it's almost 0. Again, perfectly straight, but going up, positive 1. Little fatter, blobbier thing here, so it's a little less close to 1, but it is going up, so it's positive. And again, for a linear correlation, this would have none. We could definitely find a beautiful quadratic correlation if we wanted to much later in the course. All right, moving on. I'm going to turn on that correlation coefficient. All right, this screen is a lot of stuff, but I wanted you to be able to go back to this if you needed to and work through how to find this, okay? I'm going to go right now to my calculator, and this is the calculator that I'm recommending you use, or something like this. And there's 2 ways to do this. I'm going to show you the way it should work for any version of a Texas Instruments graphing calculator first, and that way is to go second, 0, which is actually the catalog button. And then you need to scroll all the way down until you get to diagnostics on, not off. Make sure it says on. Here we go. Diagnostic on. Then you have to hit enter twice because it has to say done, as in you've turned it on. Okay. Again, that was second 0, whoops, not that, second 0. To get the catalog, we scrolled way down to diagnostics on. Make sure it's not off, but on, and hit enter. Now, when we calculate a linear regression, we're going to get an R value. If you don't do that, you're not going to see the regression correlation coefficient. Sorry, the correlation coefficient, which is from the regression. All right, there's actually a really easier way, much easier way to do this. If you happen to have this calculator, you just go to mode, and it's right down here. It says stat diagnostics. You want to make sure it's on. So if you went down here and this happened to be on off, you would just arrow to the right and hit enter to turn it on. But that only works on the 84 colors, or the 84s and above, I believe. So I just wanted to show you the shortcut. All right, once you have that turned on, you're not going to notice anything new and exciting. Let me go back to our notes though. So again, this slide talks about how to turn it on using diagnostics on. This is the shortcut. Go to stat diagnostics and turn it on under the mode key. Okay. Now, we're going to use the stat button to enter data. And you're going to need to arrow up onto the title and then hit clear to get rid of any old data. Or you can type over. But I'm going to show you something that happens, and here's a video you might need to watch if this happens to you later, okay? So when you're on your calculator, you're going to go stat, enter, and you're going to want to get rid of this old stuff. What you want to do correctly is arrow up and then hit clear, enter, and it'll get rid of all those numbers. But if you accidentally go over here and you go up and you go, oh, let me delete, look, your list 1 is gone. Okay, so then you would need to do, it's not there when you arrow to the left, it's just gone. You would need to do second delete to insert 1, and then second and the number 1, enter to rename it. And then you still have to do clear enter because it remembers all the data that was there. All right, so up onto the title, clear enter to get rid of old stuff. If you happen to delete a list, watch the video. You can't remember how I put that back there. All right. Now, what are we even using this for? Well, our first example says you're a financial advisor. You're supposed to decide about promising investments for your client, analyzing large corporations to see if they have positive trends. Is Facebook wise to invest in? Now, notice this data is a little bit old, so it's quite likely that Facebook is not as great to invest in as it was back then. Though during this quarantine, it's certainly been going nuts. All right, so in the directions here, it says we're going to use X equals the years since 2000. So we are going to call this year 10, 11, 12, 13, and 14. And we are going to put these in list 1, as those are going to be our X values. And then our Y values are going to be these numbers, and we're going to put these in list 2. All right. So we're going to bring up the calculator. Now I'm going to try to do this like this, and we'll see how it works. 10, enter. Now I'm going to use my keypad. 11, enter, 12, 13, 14, and 15. Okay, whoops, it was only 14. So I'm going to arrow back up and delete that one. Now, if it takes you longer than it did me to find all this, then you just need to pause the video, okay? Then I'm going to arrow over to the right and enter these in their matching order. So I already messed it up. 1.97, 3.71. Now I messed it up again. All right, I mess these up repeatedly, as I already have. So very important, because you get it wrong totally if you don't have the right numbers in. So proofread your list that it matches what this is supposed to be. So this last one's supposed to be 12.47. It would also give me a very bad correlation coefficient if my data was all over the place. Now, I'm going to show you how to plot these real quick, but know that this is not something you have to do for a quiz for me. But if you were to turn on your stat plot, let me full screen this. Okay, it's second y equals to turn on the stat plot. I didn't do that right. There we go, second y equals, okay? And you would hit enter to turn on plot 1. Enter, make sure it's on. If it's the boxes around off, it won't work. Scroll down, I'm gonna pick a scatter plot. Scroll down. If this does not say list 1, it's second and then 1 to get a list 1 there. Scroll down. If the y list is not 2, it's second and then the number 2 to get that one. And then the mark and color don't matter. Now, you want to not have anything in your y equals, which, by the way, I am in a very weird mode. All right, I should be in function mode. So I'm going to clear some stuff out of here. All right, the important thing, if you want to see the stat plot, is that you always have to set a window that works. It is Zoom 9. For a stat window that it sets it up all by itself automatically for you. So looking at these, I can see that they are quite linear. All right. Now, if I want to find that line of best fit, let me go back to the slides here. Okay, it says use the statistics to construct a linear model for each of these 2 categories. We're going to do gross income in a minute. We're not going to do all 3. All right, so here's what we did. We did stat right arrow, or this is what we're going to do. Stat right arrow, calculate menu, and we're going to pick the line of regression. So we have this all typed in, and now we're going to go stat button, arrow to the right, because we want to calculate a regression. And we're going to choose choice 4. It's really the same as choice 8. It just switches the variables. It doesn't matter which one you use. We use choice 4 in Precalc. I think AP Stats uses 8. We're going to pick 4. And then it has to say list 1 and list 2 here, and there has to be no frequency list. Now, as far as storing the regression equation, I would really like you to learn how to store this in Y1, which is, this is a little bit tricky. It's the vars key, which is right over here by clear. It's vars. Then we want a y variable. We want a y1. Going to arrow to the right. We are currently in function mode, should be in function mode. And then we're going to hit enter. I'm going to pick that I want it in y1. All right, that's a little bit tricky. I'll go through it one more time. It's vars, arrow to the right, enter, and then enter if you want it in y1. You do have to go down here now and calculate the equation. You can hit down arrow or just enter, and then it should show up like this. All right, this is what everybody should have gotten. If you didn't get an R value, go back to the beginning of the video and turn on your correlation coefficient or your diagnostics. All right, the correlation coefficient here is 0.96 or 0.97, very strong linear correlation, which should make sense for our graph. Now you will notice if you saved the equation correctly, it should now graph on, and you'll see how it hits your dots. Okay, so I hit graph. If you did not save it in Y1, it won't show up there. All right, one more time. Here's the buttons spelled out at the bottom of the slides here. We want it to say L1, L2, Y1. So we did list 1, list 2, after we had gone to this button 4. Okay, so we did stat, right arrow, 4. And then when this screen came up, we made sure it said L1, L2, nothing for frequency list. And then we did this crazy business down here, stat, right arrow. Oh, that's the whole thing. I'm sorry. Vars, arrow to the right a bunch of times, enter a bunch of times till we get the Y1 there. Then enter 2 more times, and we should get this, okay? This is what we came up with. Now, let's interpret what that means. It means y equals, it says right at the top here, ax plus b. Well, if we put a in, x plus b, which is a negative. So, what does that mean? Well, in our question, it was years since, and I already forgot, years since 2000, okay? So we are saying there was an increase, that Facebook stock went up in sales revenue, increased 25 or 2.52 if we round this to the nearest hundredth, about $2.52 billion per year, with starting at $23.97 billion in the whole at year 2000. Now, maybe they really were in the hole, I don't know, but it's really because our value only is increasing from year 2000. So it's if our line of best fit started in the hole. All right, one more time, what was the correlation coefficient? It's R, which is 0.969 if we round to 3 places. R usually don't round too much. Is this a good model? Yes, because it's close to 1. Sorry, that's so crooked. All right, moving on. We're going to use this same example in terms of leaving our first list to be 10, 11, 12, 13, and 14. But this time, we're going to put these numbers in list 2. So hopefully you remember. It is stat, right arrow. Nope, lied. Stat, enter. And we're going to replace these and put them in list 2. Let's see. We're going to put, where's those numbers? There they are. 148, 285, 373, 611, and 1028. Now I wasn't looking, so I probably need to go back and fix something. Yep, this one should be 2.85. All right, looks like I actually got the rest right. Okay, then to get to the equation of best fit, it's stat, right arrow, choice 4. I actually, in a minute, am going to have both equations. So I'm going to go ahead and store this in Y2. And I'm also going to teach you a shortcut. Do you see right up here, there's a little F4, okay? If you push alpha trace, look what it brings up. These are all your choices. You could just go alpha trace down to Y2 and hit enter. I'm not sure I was in the right box when I did that. Oh, I was. Okay. So stat, arrow to the right, choice 4, then go down to the store, and the shortcut is alpha trace. And then I'm actually going to store mine in Y2 because in a minute I'm going to have both Y1 and Y2 available to me then, the equations. Okay, enter. Now this is my equation that I came up with this time. All right, so this time it's $2 or 2.9, we'll say, billion dollars of, and these were, I already forgot, gross income, starting from negative 20.14 in year 2000. All right, we are, I believe, on the next question supposed to use that. I hope I have it on this slide already. Do I? Nope. All right, there was our second one. And let me go back and find the first one. Just putting these on the slide so it's easier to fill this in and you know where I'm getting these numbers from. All right, so the sales was the first one, and our increase was about 2.52 billion per year. Starting from negative 23.97 in year 2000. The gross income model we came up with was that it is growing by 2.09 if we round to 2 decimals, and that's billions per year, from a negative 20.14 right here for year 2000. So that's how those would be interpreted if you want to put that in your notes. All right, are the slopes significantly different from each other? Well, it does appear that sales are growing faster than the gross income model, okay? So it says interpret what that could mean for the company, and I don't really know how Facebook works enough to say, but I'll just say over here that sales are growing faster. I don't know how gross income is calculated. If they had more expenses, is that why it's not growing as fast as sales? But all right. Now we're supposed to predict. That's always the point of this, is can you make a prediction? And it says use the model for 5 years into the future. Well, they want us to figure out 2015 and 2019. If you have two options here. You could put a 15 into this equation and a 19 into this equation for x. And over here, you could go ahead and put a 15 in and a 19 in for this blank for x. And you could just do that from the home screen. Let me just do one of those. 2.52, or I can use the whole thing, doesn't matter. 2.52 and negative 23.97. So on my home screen, I would say 2.52 times 15 minus or plus negative, either way, 23.97. And I get 13.83 as my predicted answer. Is that what I said? 13.83? It went away. Yes. All right, and then I would change that to 2019. Now, I could be real slick here and hit enter and go back and change this to a 19 and hit enter. 2391. All right, but I have a sheet even better for you. If you left those equations in, if you right now go to second window and make sure that this is counting by ones, okay, right here. The rest of it doesn't matter. Auto you need on, but everybody's is probably on auto. Make sure this change in table is 1 and that these are selected to auto. Then you can go second, whoops, not that, second, okay, clear, second graph, and look at the table. Now, we want year 15, so if I scroll down, year 15 is 1377, okay, And that was using the first equation. Now we rounded, and that's why we got 1383. If we had used all the decimal points, we get 1377. It does make a difference a lot in using the full equation, and that's why I want you to learn to store it. Okay? But this red is y2, and if you go to y equals, this is the equation it's using for y1 and y2, which are the two equations we have here. So if we go second table, or second graph to get to the table, the red one is 11.15 if we round. And for 2019, the red one gives us 19.49. So that was an easy way to predict if we stored the equation. But if you can't remember all that, again, just go clear, go to the home screen. Oh, sorry, I'm in a table, so I have to quit. Second mode to quit. I can always just go to the home screen and type this in. So if it had been 2.086 or 09, I'm just trying this very bottom one here, times 19 years, and then it was plus negative 20.14. Okay, I got 19.57 and we got 19.49. It's always more accurate to use the stored equation, but I'm pretty sure that you can use the rounded one and get a close enough approximation for my quizzes. All right, I have one more quick example. This one says use years since 1940. It is a blogger writing about the cost of eggs, and we want to predict the cost in 2050. So here's some data. We're going to use years since 1940. So this will be year 0. If we subtract 1940 from all of these, this will give us year 15. This would be 30 years later, and this one would be 50 years later. So you got to remember to take the year minus 1940, as it said to use years since 1940. All right, so real quick, I'm going to go here, stat, enter, up onto the title, clear, enter, over here, clear, enter, up onto the title, clear, enter. All right. I probably should pause the video, but I'm going to try to just type fast. Only 4 numbers, I can do this, right? And the other 4. Did I get them in right? What do you know, I did. Okay. Now it says construct the scatter plot. I'm just going to go through this one more time. Second, y equals, if you want to turn a plot on, using list 1 and list 2, because that's the lists I type my numbers into. The trick is you have to remember to clear out anything in your y equals, and you have to remember to do that zoom 9. So this is our egg prices. Okay, and there's a gap over here because remember we had a prediction for 30 years and then it jumped to 50 years. That's why they're kind of uneven. All right, we're going to go to the next question here, because I think it, or maybe it's still on this screen. Oh, it asks us to predict. Well, I don't know. We're going to predict while we're still on this screen. So we're going to go stat, right arrow, choice 4. I am going to store this and I'm going to use my shortcut, and I cleared out everything so I can store it in Y1 again. The long way is vars, arrow to the right, enter, enter to store it in Y1. The shortcut is alpha trace, and then pick one of your Y variables to put there. All right. Then enter a couple times to calculate, and we get this, 0.019, 0.239. It is a good fit because our R of 0.983 is a very good fit. Let's see if that's what I have down here. Yes, it is. Okay, I'm going to copy that in case it's not on the next screen. And, oh, it is right here. All right, so I have put it on this screen. So I'm going to go through these real quick. Find the linear regression equation and what it means. Y equals 0, it says A, and I'm going to write 0.02 if I round to two places. X plus B is 0.24 if I round to two places. All right. So what would that mean? Well, this is years since 1940. So approximately 2-cent increase per dozen eggs per year. It is per dozen, but for a dozen eggs per year since starting in 24 cents in year 1940. Now, if you go back, I don't think it was actually 28 cents. But see, what happens is, if we go to the calculator and go to the graph, it's missing this bottom dot a little bit to try to fit all these in. So that's why it doesn't say 0.28 there. All right, predict 2050. So we have a couple options. We could go to the table. Since I saved this, I don't want to scroll all the way down. If I was calculator savvy, I could go back here and say start with 50 or 49 and count up. And it would tell me 50 is about 123. Or if I just go back to my home screen and I type this in, 0.02 times, what year are we doing? Actually, isn't it supposed to be, I didn't do that right. It's supposed to be years since 1950, which is what, 110 years later. Wow. Plus 0.24. So I got a prediction of 244. So I did it wrong originally because I thought we were starting in 2000. 2050 minus 1940 is 110 years. So if I wanted to use, and when I put in 110, I got 224. Or 244 as the cost of a dozen eggs. If I had used the table and scrolled to 110, or changed my starting point to 110, it says it's almost 241 and not 244. And again, that's rounding because we rounded here. All right. Then it says, last question, in what year would you expect it to be over $4 a dozen? So we want the Y to equal 4, so we work backwards. If we subtract, thinking that's 376, and we divide. So we did 4 minus 0.24 divided by 0.02 is 188 years. Added on to 1940. Would hit $4 a dozen in year 2128. That's a ways away. All right, so you are now ready to do the practice on both the word problems and the linear regression models. There are only 3 of these linear regression problems assigned, 3 very short lists for you to enter. So The video is long, but the lesson is not. The practice is not. Thanks, guys.